According to the 2020 National Electrical Code, it is required to bond the seal tight to the skin of the can. Section 250.24 C6 states where a raceway or cable is used as a grounding electrode conductor, it shall be bonded to the grounding electrode system at the service equipment or at the source of a separately derived system. The skin of the can refers to the metal enclosure of the meter socket, which is connected to the grounding electrode system. Bonding the seal tight to the skin of the can ensures that the raceway is properly grounded. Bonding the seal tight to the neutral lug of the meter socket is not acceptable because the neutral conductor is not part of the grounding electrode system. Let's delve deeper into the requirements for bonding seal tight, also known as liquid tight flexible metal conduit, in temporary power applications with specific reference to the National Electrical Code. The primary reason for bonding any metallic raceway, including seal tight, is to provide a low impedance path for fault current. This low impedance path facilitates the rapid operation of overcurrent protective devices such as circuit breakers or fuses in the event of a ground fault. Without proper bonding, a ground fault could energize the metallic raceway, posing a significant electrical shock hazard. Section 250.4 A5 of the NEC emphasizes the importance of effective grounding fault current paths. It states that electrical equipment and wiring must be installed in a manner that creates a low impedance circuit facilitating the operation of overcurrent devices. This section underscores the fundamental principle that grounding and bonding are essential for electrical safety. Now let's examine section 250.24 C6 more closely. This section specifically addresses the bonding requirements for raceways and cables used as grounding electrode conductors. The grounding electrode system is the network of interconnected grounding electrodes such as ground rods, metal water pipes, and concrete encased electrodes that provides a connection to the earth. The intent of 250.24 C6 is to ensure that any metallic raceway or cable used to connect to the grounding electrode system is effectively bonded to that system. This means that the raceway or cable must be electrically connected to the grounding electrode system in a manner that provides a reliable and low impedance path for fault current. The phrase at the service equipment or the source of a separately derived system indicates the points where the bonding connection must be made. In the case of a temporary power panel supplied from the utility, the service equipment is typically the main service disconnect and overcurrent protection located at the building or structure. The source of a separately derived system, such as a generator or transformer, would be the output terminals of that system. The requirement to bond the seal tight to the skin of the can, which is the metal enclosure of the meter socket, is based on the principle that the meter socket enclosure is connected to the grounding electrode system. The grounding electrode conductor, which is typically a copper wire or bus bar, connects the meter socket enclosure to the grounding electrodes. By bonding the seal tight to the meter socket enclosure, you are effectively bonding it to the grounding electrode system. This ensures that the seal tight is properly grounded and can safely carry fault current back to the source. In contrast, bonding the seal tight to the neutral lug of the meter socket is not an acceptable practice. The neutral conductor is a current-carrying conductor that provides a return path for normal load current. It is not intended to serve as a grounding conductor. While the neutral conductor is typically grounded at the service entrance, it is not part of the grounding electrode system. Bonding the seal tight to the neutral lug could create a parallel path for neutral current, which could lead to circulating currents and potentially create a shock hazard. Furthermore, bonding to the neutral lug does not provide the same level of protection as bonding to the grounding electrode system. In the event of a ground fault, the fault current may not have a low impedance path back to the source, which could delay the operation of overcurrent devices and increase the risk of electrical shock. To ensure proper bonding of seal tight, you should use appropriate bonding fittings that are listed for use with liquid tight flexible metal conduit. These fittings are designed to provide a secure and reliable electrical connection between the seal tight and the metal enclosure. When installing the bonding fitting, make sure to remove any paint or corrosion from the metal surface to ensure a good electrical connection. You should also tighten the fitting securely to prevent it from loosening over time. In addition to bonding the seal tight at the meter socket enclosure, you may also need to bond it at the temporary power panel. The NEC requires that all metallic raceways and enclosures that contain circuit conductors be bonded together to form an effective ground fault current path. This bonding ensures that any fault current will have a low impedance path back to the source, regardless of where the fault occurs. When bonding the seal tight at the temporary power panel, you should use a bonding bushing or a grounding lock nut to connect the seal tight to the metal enclosure. The bonding bushing or grounding lock nut should be installed in accordance with the manufacturer's instructions. It is also important to ensure that the temporary power panel is properly grounded to the grounding electrode system. This can be accomplished by connecting a grounding electrode conductor from the panel to a grounding electrode, such as a ground rod or a metal water pipe. The size of the grounding electrode conductor must be in accordance with NEC Table 250.66. based on the size of the service entrance conductors. Furthermore, it is essential to verify the integrity of the grounding and bonding system using appropriate test equipment. A ground impedance tester can be used to measure the impedance of the ground fault current path. A low impedance reading indicates that the grounding and bonding system is effective. A high impedance reading indicates that there is a problem with the grounding and bonding system, such as a loose connection or a corroded conductor. In addition to the general requirements for bonding seal tight, there may be specific requirements that apply to temporary power installations. Section 590 of the NEC covers the requirements for temporary installations. This section addresses issues such as the use of ground fault circuit interrupters, GFCI protection, and the installation of temporary wiring. Section 590.4 D specifically addresses the grounding of temporary services. It requires that all metal enclosures be grounded in accordance with Article 250. This means that the seal tight and other metallic raceways must be bonded to the grounding electrode system in the manner described earlier. In summary, the proper way to bond seal tight for temporary power, according to the 2020 National Electrical Code, is to bond it to the skin of the can, which is the metal enclosure of the meter socket. This ensures that the seal tight is properly grounded to the grounding electrode system and can safely carry fault current back to the source. Bonding the seal tight to the neutral lug of the meter socket is not an acceptable practice. Always refer to the latest edition of the National Electrical Code and consult with a qualified electrician to ensure that your electrical installations are safe and compliant. Remember that electrical work can be dangerous, and it should only be performed by qualified individuals who have the necessary training and experience. Here are some additional points to consider regarding bonding and grounding in electrical systems. Firstly, the size of the grounding electrode conductor must be sufficient to safely carry fault current. NEC Table 250.66 provides guidance on the minimum size of the grounding electrode conductor based on the size of the service entrance conductors. Secondly, the grounding electrode conductor must be installed in a protected manner to prevent damage. It should be run in conduit or otherwise protected from physical damage. Thirdly, all grounding and bonding connections must be made with approved fittings and connectors. These fittings and connectors must be listed for the specific application. Fourthly, regular inspections and maintenance of the grounding and bonding system are essential to ensure its continued effectiveness. Connections should be checked for tightness and corrosion, and any damaged component should be replaced. Fifthly, it is important to understand the difference between grounding and bonding. Grounding is the connection of electrical equipment to the earth. Bonding is the connection of metallic parts to create an electrically conductive path. Both grounding and bonding are essential for electrical safety. Sixthly, the NEC contains numerous requirements for grounding and bonding. It is important to consult the NEC to ensure that your electrical installations are compliant. Seventhly, local codes and regulations may have additional requirements for grounding and bonding. It is important to check with your local authorities to ensure that your electrical installations comply with all applicable codes and regulations. Eighthly, proper grounding and bonding are essential for protecting people and property from electrical hazards. By following the requirements of the NEC and consulting with a qualified electrician, you can ensure that your electrical installations are safe and reliable. 9th, always disconnect power before working on any electrical equipment. This will help to prevent electrical shock. 10th, if you are not comfortable working on electrical equipment, hire a qualified electrician to do the work for you. Attempting to perform electrical work without the proper training and experience can be dangerous. Remember, safety is the top priority when working with electricity. Always take the necessary precautions to protect yourself and others from electrical hazards. The information provided here is for general guidance only and should not be considered a substitute for professional electrical advice.